Chapter 10, Measure Figures, Lesson 5, Volume and Surface Area of Composite Figures. The essential question for the chapter: how do measurements help you to describe real-world objects? We're on the last lesson of the chapter, Lesson 5, and we have two objectives: to find the volume of a composite figure and to find the surface area of a composite figure. So how do we get the volume of a composite figure? What we're going to do is we're going to separate or break down the figure into solids whose volumes you do know how to find. Here I have a composite figure and I need to find its volume. So what I'm going to do is decompose it into two solids that I do know how to find the volume of. Let me show you this in SketchUp. In SketchUp right now I have this solid, and what I'm going to do is I'm going to make a slice right here, and that'll give me a rectangular prism here and another rectangular prism here, and I know the volume formulas for a rectangular prism. Another way to visualize this is with wooden blocks. So here I have a student that's going to show you the composite figure, and we don't know how to find the volume of it when it's together like this. So we're going to decompose it, separate it into two figures that we do know how to work with. In this case, two rectangular prisms, and we're going to find the volume of each one and add them together. I'm going to make a slice right here, and now break it up into two solids. So here are the two solids when I decompose the figure. Now where did I get this 8? That 8 comes from this side. This 6, that comes from this edge here, but it doesn't say it's 6. But what I do know is that this edge is equal to this edge, so I knew that was 6. Now where did I get the 8? How did I figure out the height? It doesn't tell me the height from here to the red line, but I do know that the whole distance from the bottom to the top is 16, and that the top part is 8 inches long there. So if the whole thing is 16 and part of it's 8, what must be left is 8, and that's how I knew the height of this. This piece here is being represented by this solid, and it's a 16 by 8 by 6, and that's kind of easy here, 16 by 8 by 6. So now I'm going to find the volume of each piece and add them up. So I'll call this one volume 1 and this one volume 2. So volume 1, the volume formula is uppercase B times H. So now I'm going to find out what B is. B is the length times the width. So that comes from 8 times 6, which is 48. Going back to the formula now, I know that B is 48 now, times the height of the prism, which is 8. So now I know V1 is equal to 48 times 8, which is 384. Now I'm ready to find volume 2. I'll do that in a different color so we don't get mixed up. V2 is equal to BH. Again, we always like to write that down. Now I'm going to get the area of its base, which is 8 times 6, which is again 48, just like the other one. B is 48 times its height, which is 16. So now I'm going to do 48 times 16 on the calculator, and I'm going to get 768. Now to find the total volume, I'm going to add volume 1 plus volume 2, which is equal to 384, that's the first one, plus the second one, which is 768, and then I'm going to add those two together, which gives me a total volume of 1,152. But don't forget the units of measurement at the end. We're in inches and we're doing volume, so that's inches cubed. And that's how we get the volume of a composite figure, by breaking it down into solids that we do know how to get the volume of. Find the volume of the composite figure. They actually tell you how to break it up, how to decompose it. They tell you to find the volume of the cube and then the volume of the pyramid. We're going to add them together, and then we're going to round the answer to the nearest tenth. Let's look at SketchUp to look at why that makes sense. Here we have a solid that looks similar to the one in the problem, and what I'm going to do is decompose it. going to select the shape on the top, the solid on the top, and I'm going to move it. And as you can see, all I have to do is find the volume of the pyramid, find the volume of the rectangular prism, and then add those two numbers together. So here I have the rectangular prism, which comes from the bottom, and I'll call that V1. And here I have the pyramid, and I'll call that V2 for the volume of the second one. So now I need the volume formula for rectangular prism, which is uppercase B times H, and I'm going to do the base first, the area of the base, which is 8 by 8, which gives me 64. Then going back to V1, I replace B with 64, and I multiply it by the height of the rectangular prism, which is 8. Now you can do the scrap work or use your calculator, which will give you 512. Now we're ready to find the volume of the pyramid. We'll call that V2. Now the volume of the pyramid, the formula is different. It's 1/3 BH. Going to find out what B is. Now B is in the shape of a square, so I can use length times width, which is 8 times 8, which gives me 64. So now I'm going to do 1/3 times 64 times the height of the pyramid, which goes from the vertex down to the base at a right angle. Remember, you don't use the slanted height when you're dealing with volume, and that's 5 feet. Then you would use your calculator to type this in, and there are two ways you could do it, and I'm going to show you on the next page. The first way I'm going to do it is to use the fraction key. So I have 1/3, so I would type 1 in the calculator. Fraction bar I would use the ABC key for, then the 3, then the multiplication symbol, then times 64, then times 5, and that's how it entered on the calculator. And that's going to give me 106.6666 forever. Now I prefer another way. I like to do 64 times 5 and then divide by 3, because multiplying by a third gets me the same answer as dividing by 3. So here's how I type on the calculator. 64 times 5 and then divide by 3, and I'll get the same answer. I find it to be a little bit less work, but I'm not done yet. Now I'm ready to find the total volume, which is equal to the volume of the rectangular prism, V1, plus the volume of the pyramid, V2. V1 was 512. V2 was 106.6666. Dot, dot, dot. Now, when you add these two numbers together, you're not typing 106.666 in the calculator only and then adding 512. You're using the original long number that was in the calculator and then adding the 512. Sometimes that makes a difference in what the answer is. So you definitely want to have the original number in there. When you add these two numbers together, you're going to get 618.6666 dot, dot, dot. And now you're ready to round to the nearest tenth. I'm going to use the about symbol, and that 6 is going to round that 6 to a 7. So 618.7. Now you look for the units of measurement, and the unit of measurement is in feet. So you're going to write feet cubed. And that's it for this problem. Find the volume of the composite figure. Alright, I'm going to break this up into 3 pieces by making a slice here and here. And I'm going to find the volume of this piece, the volume of this piece, and the volume of this piece. I'll call the top one V1. And since it's a rectangular prism, it's uppercase B times H. Now I'm going to find the area of the base. Now I know that the base is 12 centimeters long that way. I don't know how long that edge is, but I can figure it out. I go down to the bottom over here, and I know that that edge is 6. So this edge must be 6, which means this edge must be 6. So I'm doing 12 times 6, which gives me 72. Now going back to V1, I replace B with 72, and now I have to multiply it by the height of this rectangular prism. The thing is, they don't tell you the distance from the red slice to the top of the table, but you can figure it out. Over here you see that 9, and this 9 represents the distance from the bottom of the table to the top of the table. So I know the whole distance is 9. I know on this part, from this leg to the bottom part of the table, that it's 7. So the difference between them must be this distance. And how do you get from 7 to 9? You must add 2 centimeters. Or another way of doing it, 9, the total distance, minus part of the distance is 7, gives you what's left, which is 2. So volume 1 is equal to 72 times 2, which is 144. Now I'm going to do this piece over here. So I'll call that volume 2. So this piece right here. So I know I'm going to do capital BH again. Going to get the area of the base. And I know that it's 6 by 1. So that's 6. So I'm going to replace B with 6. And I need to multiply it by its height. Now remember, the height is not 9. It only goes to the bottom part of the table. So that's 7. So V2 is equal to 42. Now I notice that this side over here is symmetrical with this. So volume 3 is the same exact volume as volume 2, 42. Now I'm ready to find the volume of the entire solid. So V is equal to V1 plus V2 plus V3. V1, that was 144. V2 was 42. And V3 was 42. Then you would add all of these numbers up, which is 228. Look for the unit of measurement, it's centimeters. And remember, it's volume, so it's cubed. And that's it for this problem.